Hassler here. I'm going to do the notes for 12.3. So we've been practicing solving systems by graphing, but we're going to take a look at inequalities. So instead of graphing equations, we're going to graph inequalities and what the solution to a system of inequalities looks like. But before we can graph two inequalities at one time, we should really discover what happens when you look at just one inequality at a time. And so we're going to use Desmos to get us started. I'm going to help you through this first one, this one right here. And so we're going to go to Desmos and we're going to type these three in. I'll do that with you. And so when we do that, you can either use the keyboard option that's down here at the bottom, or you can just use your keyboard. But we have y is greater than x plus 1. Ooh, that looks pretty. And we have y is greater than negative 1/2, arrow over, x minus 3. Well, that's pretty. And we have y is greater than negative 2. So you are going to want to use this keyboard bar at the bottom for some of the others. When you have things like greater than or equal to, those keys are down here when you click on this keyboard. But what we want to do is we want to write things down that we notice when we graph all three of these. Now, a couple of things I notice is that over here by the inequality, I have this colored in circle with this dashed line. One part is solid, one part is kind of faded, like a darker color versus a lighter. If you click on those, it'll turn those graphs off, so you can just look at one graph at a time. When I look at this first graph, I notice that there's this dashed line and that I have this shaded area. Half of my graph is shaded. And it looks to me like, if I had to talk about like above this line and below this line, that the area above that line is the part that got colored in. Again, if I click that one off and turn the middle one on, I have this dashed line. And again, if I think about above the line and below the line, the area above that line is shaded. I guess you could kind of think about this as to the right of the line and to the left of the line. Same idea, to the right of the line or above this line, I get this colored in part. If I shut that graph off and turn the last graph on, I still get this dashed line. So that was common to everything. And there's a clear top and bottom. There's a clear above and clear below. And it is the above part that gets shaded. And so going back here to the notes where it says, graph each set of inequalities and write what you notice. There are two patterns that I noticed when I looked at each of these linear inequalities. And one of the things that I noticed is that all of them had these dashed lines. The other thing I noticed is that we are shaded or colored in, but we call it shaded. We are shaded above, or in parentheses, I'll just say to the right, depending on how slanted that line is. It might look more like it's left versus right. Shaded above or to the right of the line. So those are some things that I noticed when I look at these three inequalities. What I'm going to have you do is pause the video and complete 2, 3, and 4. Notice that the inequality symbols are what's different, but the line itself is the same. And so I still have y and x plus 1. It's just that I have a greater than or equal to bar. That should save you on some typing, that you're just changing the symbol. So you're going to pause the video 2, 3, and 4. When you're ready, hit play and check your answer. All right, so this is what you should have come up with after graphing in Desmos. In part 2, I noticed that this greater than or equal to bar is going to cause me to have a solid line. It's kind of like when we did open circles versus closed circles, right? An open circle went with no equal bar, and that matches a dashed line. There are holes in my line. Versus a closed circle matched that equal to bar, and that produces the solid line, okay, totally filled in. I also noticed that there is some shading. So when I have this greater than symbol, that greater than symbol looks like I'm shaded above, versus this less than symbol or less than or equal to looks like I'm shaded below. That seems like it should make sense. Greater than, above, less than, below. And so we're going to go ahead and organize that in our graphic organizer here, just to make sure we are all on the same page for our understanding. When I have a greater than symbol, I have a dashed line, and I am shaded above or to the right. If I have a greater than or equal to symbol, that's when I get this solid line, but I'm still shaded above or to the right. If I have a less than symbol, I get, again, a dashed line. If there's no equal bar, it's a dashed line. Less than, though, means I'm shaded below or to the left. And less than or equal to, the equal to bar creates that solid line, but less than means I'm still shaded below or to the left. So we're going to do a couple of examples of just doing one inequality at a time. And then we'll put this together and talk about what the solution means. So let's look at this first problem. In this first problem, we have a slope-intercept equation. I have my slope. I have my y-intercept. So I plot that y-intercept first at -5. A slope of -3 means that I could count down 3, but I'm off my grid. So I could go up 3, but I have to go to the left 1. A slope that's negative means that I have a decreasing line. And so I want to make sure that I have a decreasing line. So up 3, but to the left 1. And just like when we graphed before, we want to extend across our grid. Now I really have to pay attention to my inequality symbol. And my inequality symbol says less than. Now that's going to tell me two things. That less than is going to tell me that I have a dashed line. So be careful, don't connect that yet. And it's also going to tell me that I'm going to shade below or to the left of my line. This line is pretty slanted. So below doesn't make as much sense, but to the left would match that idea, okay? I'm going to come back here and I'm going to put in my dashed line. What that means is that you need to go through those points, but you don't have a solid line. You have some space in between these little line segments. And then shaded below or to the left means that I'm going to color in this side of the line, to the left of the line. It says circle the points that satisfy the inequality. And what that means is I'm going to circle the points that, that would fit in that shaded region. So here, the point 6, 3 is right here. That is not in my shaded area. That would not make this statement true. I mean, I could check it. I could replace 3, the y with 3, and say, is 3 less than -3 times the x, which is 6 minus 5? That is 3 less than -18 minus 5. That's -23. Yeah, 3 is not less than -23. So it does not make the inequality true. It's not in the shaded region. Crossing that out. How about -4, -1? So -4, -1 would be right over here. And that is in the shaded region, so that would make my statement true. Again, if I were to substitute that in, I would have -1 less than -3 times -4 minus 5. That's -1. That's 12 minus 5, which is 7. -1 is less than 7, so it works. All right, what about if I had the point -3, 4? So -3, 4, oh, that's this point right here. Now, this is on a dashed line, kind of like the open circle idea. If it's on a dashed line, then it is not going to be part of my solution. Again, I can check it. Is 4 less than -3 times -3 minus 5? Well, -3 times -3 is 9. 9 minus 5 is 4. So is 4 less than 4? No, 4 can't be less than itself. If there were an equal bar here, then yeah, that would be a solution. But there's not an equal bar here. 4 is not less than 4. So if it's on a dashed line, then it is not a solution. All right, here's the 0.00. That is not in the shaded region, and so that is not a solution either. All right, so you're going to try problem 6. Let me get you started. 6 is in point slope form, and so my slope is 1/4. And that ordered pair, remember, is opposite sign, so -3, 1. You've got to pay attention to your inequality symbol, right? And so your inequality symbol tells you if it's solid and how to shade. And then you're going to check to see if the points given are in that shaded region. Press pause, give it a try, and then we'll check our answer. Okay, so we should have a line that looks like this. I plotted a point at -3, 1. I had a positive slope, so my line's increasing. Because I have this less than or equal to, the equal to bar means that I have a solid line. The less than or equal to means I'm shading below. There's a clear above and below for this line versus left or right. So below. Now I have to check. So is 6, 5 in that solution set? Well, here's the 0.65. 1, 2, 3, 4, right here. Nope, that is not in my solution set because it's not in the shaded area. How about -3, 1? Oh, well, that's on the solid line. If it is on a solid line, then it is going to turn out to be a solution. I could check it by substituting numbers back into my equation. So the 1 minus 1 is that less than or equal to 1/4 times -3 plus 3. Well, that's going to give me 0. And over here, I'm going to get 0. Is 0 less than or equal to 0? Yeah, 0 is equal to itself. Okay, and so it makes the statement true. So over here, dashed, when I'm on a dashed line, I'm not a solution. When I'm on a solid line, I am a solution. All right, how about 2, -4? 2, -4 is here. Yep, that is in my shaded region. And how about 0, 3? Well, 0, 3 is not in the shaded region, so that's not a solution. Now, we're talking about systems, and systems means that I'm looking at 2 equations or inequalities at a time. And so now that we have graphed 1 inequality, we're going to graph 2 inequalities on the same grid and see what happens. Now, in order to try to make this a little easier for us to understand, we went ahead and we gave you the graphs with the inequalities. We're going to shade the correct regions together and then use that shading to determine whether the point is a solution. The trick here is, though, you have to know which line goes with which. So when I look at this first inequality, it has a y-intercept of 6 and a negative slope. So that would be this one right here. It's dashed, it has less than. And so because it has less than, I'm going to shade below. So let's just go ahead and shade everything below that line. Everything. Okay, even though we cross over the other line, all of the grid that is below that dashed line gets colored in. Now don't color too dark because I have to put another color over top of that. Okay, so that means my other line, this second line here, is a y-intercept of -4 and a slope of 1. That's this dashed line here. Dashed because there's no equal bar. And it says all the y values greater than or equal to that. So I got to shade above this line. And so I'm going to go ahead, everything, all the way across your grid, everything above that line gets shaded. And what we should notice is that we get this double shaded region. Right in here, we get this double shaded region. And that is going to be our solution area. Remember, for systems, the solution is the points that are in common to both equations, the points that make both equations true. That's the same thing for inequalities. It's just that inequalities have many points in common because inequalities look at these shaded areas. And any point in the shaded area makes that inequality true. Well, for a system, any point in the overlap region or the double shaded region would make that system true. And so we are asked to determine if the point 2, 3 is a solution. So if I plot the point 2, 3, the point 2, 3 is right in here. And the answer is yes, that is in the overlap area, that is in the double shaded region. So you're going to press pause, and you are going to shade problem 8 and determine if 4, -2 is a solution. Okay, so here's where your shading should be. My pink line, the top line, says greater than or equal to, so that's the solid bar, the solid line, and it's above. My blue shaded, that says greater than, so that's the dashed line, and that's to the right or above. And that overlap area is my highlighted green area. Now I got to check, is the point 4, -2, and that's this point right here, a solution? And the answer is no. While it is in one shaded area, it is not in the overlap or the shared shaded area. And so that would not be a solution to the system. All right, let's keep going. So your job is going to be to graph entirely the line and the shaded region and determine if certain points are a solution and explain why. So I will do 9 with you, and your job is to do 10. And so again, I like to use my colors so that I can keep track of things. This is in point slope form, and so this is the point 3, -4 with a slope of -2/3. So 3, -4 puts me right here. A negative slope means that my line is decreasing. I could go down 2 to the right 3, or I could go up 2 to the left 3. And again, just like before, you want to extend your line across the grid. My inequality symbol has no equal bar, it's just greater than, and so I have a dashed line. I go to connect these, put some arrows on that. I'm going to wait to shade. I'm going to wait to shade so that I can clearly see the points for this second line. So just like up above, the lines were already graphed with no shading. It makes it easier that way. I'm going to graph this one, and then I'll go back and shade. Okay, so this has a y-intercept of 4 and a positive slope, so my line should be increasing. I can go up 3 to the right 5, or I could go down 3 to the left 5. Now, this has an equal to bar, which means it's a solid line, so I'm going to connect with a solid line all the way through those points. Now I'm going to go back and I'm going to shade appropriately. So again, this is greater than, my pink line is greater than, so I'm going to shade above that dashed line. I'm going to go back to my blue. This one says less than, so I'm going to shade below my blue line. And then I like to highlight or circle or do something to acknowledge the fact. Sorry, wrong. That I have this double shaded area in through here. This is my region that overlaps. And so it says, is the point -4, 4 a solution? Well, let me graph -4, 4. And so if I graph -4, 4, so -4, 4 would be right here. That is only in the pink area, so I'm going to say no. And I'm going to say no because it is not in the, I'm going to call it the double shaded region. You can say no, it's not in the overlapping region or area, okay? B says, is the point 1, 2 a solution? So let's check it. 1, 2 would be this point right in here, if you can see my red point growing there. And my answer is yes. This is in the double shaded region. Okay, and so that's how that works. So you're going to do problem 10. Ooh, be careful with that first one. What type of line is that? Okay. When you go to draw it, it should look horizontal. All right. But remember, you want to determine if it's solid or dashed and how to shade. And then once you have that graphed, then you're going to determine if it's a solution to the system, the point that's given. So I'm going to press pause. You're going to give it a try. And when you're done, go ahead and hit play and check your answer. So here's what your graph should look like. You should have a dashed line for the horizontal line, that first line there, and you should have a solid line for the second line that's in slope-intercept form. All right, it says, is the point negative 4, 5 a solution? So negative 4, 5 puts me right here. I've got my black dot going, and that's on a dashed line. So remember, we said no. And it's not because this point, even though it borders that double shaded region, it's on a dashed line. And a dashed line will never have points that make true statements that are on that line. So no, the point is on a dashed line. Okay. All right, let's take a look at 4, negative 2. So 4, negative 2 is this point down here. Again, I got my black point going here. I'm on my blue line. Now, this borders the double shaded region. And it's on a solid line. And so you say, yes, okay, it's on a solid line. And you need to state both. And borders the shared region or shared area. Okay, and so that's the difference between those two. So you have an assignment to complete per your teacher to practice this in Delta Math. And so use these notes to help you. And if you have questions, let your teacher know.